Rajeshwari MJ. She pursued her BE in Electrical and Electronics at the People's Education Society College of Engineering, Mandya. She pursued her MTech in VLSI Design and Embedded Systems at the Sri Jagadguru Balagangadharanta Institute of Technology, Bangalore. Her personal skills lie in good verbal and written communication skills. Her areas of interest lie in OOPS with C++, renewable energy sources, HVDC transmission, digital relays, automotive electronics, advances in VLSI design. She has also had papers presented at the national level, such as the Innovative Architecture for SoC Multi-Core Hybrid Processor, presented at the RNSIT, Bangalore.
Welcome to UGC lecture series of BSc Applied Electronics. Today we are dealing with the subject Semiconductor Devices and Integrated Circuits of semester 4. Let's start with the unit 5. The topics that we are going to cover: integrated circuits classification, LSI, that is large scale integrated circuits, MSI, that is medium scale integrated circuits, VLSI, very large scale integrated circuits, and fundamentals of monolithic IC technologies. These three topics that we are going to cover today. Let's start with the integrated circuits or ICs, which is commonly called as ICs. What do you mean by integrated circuits? Let's know the history, how it comes. Before ICs, there were discrete components, that is the resistor or capacitor, the passive components, and active components like transistor, diodes are separately placed on a printed circuit board and it is interconnected with the wires. But as the design of electronic appliances increases, we are going to use more number of these kind of discrete components, which is large in size, and this makes the electronics device or appliance looks huge and it is not looking good. So, as there is a need to reduce the size, so from discrete we have come up with a new technique called miniaturization of these electronic devices and placing on a single chip, single silicon chip or wafer. How these ICs are manufactured and how we are going to fabricate this, what is the symbol and what are the process of fabrication, how these ICs are different from the discrete components, what are its advantages, everything that we are going to cover in this session. And as I said, the integrated circuits is having its the components like resistor, transistor, diode or capacitors are miniaturized and placed on a single wafer or single silicon chip. This is called as integrated circuit. And first integrated circuit was developed in 1950s by Jack Kilby of Texas Instruments and Robert Noyce of Fairchild Semiconductor. This is how the physical IC looks like. We can expect there is a millions of billions of transistors inside, and consists of millions of circuits, resistors which are interconnected each other. This forms a integrated circuits. Next we learn some of the advantages of ICs. What are the advantages? Why we need go for ICs than discrete components? Because ICs are small in size and it is low cost, improved performance, high reliability and ruggedness, low power consumption. As we know, today the world is moving towards low power electronics and the demand, the consumer demand is only for electronic devices which going to use less power. That is why we can use ICs because of its low power consumption and less vulnerability to parameter variation. So, easy troubleshooting, increased operating speed, less weight and volume, easy replacement. The replacement is very easy. If an IC is gone, means we can simply remove that IC and we can fix a new IC. That is the easiest way that we can replacement of IC. These are the advantages of ICs, and this is how an integrated circuit looks. This is a circuit. These are many ICs. These are connected internally inside. These are many ICs and whole things forms a integrated circuits on a printed circuit board. Next, some of the disadvantages of ICs. If any component in an IC is failed, we have to remove the whole chip. The entire chip has to be replaced. We can't remove a single component from an IC. It is not possible. We need to remove the entire chip and we need to fix a new IC for it. This is the main disadvantage, and also it is neither convenient nor economical to fabricate capacitance exceeding 30 picofarad. If the capacitance is exceeding 30 picofarad, this IC's fabrication is not economical. Therefore, for high values of capacitance, discrete components exterior to ICs. So, if the capacitance value is higher, then we are going to use a discrete components exterior to the IC and which are interconnected together if the capacitance is more than 30 picofarad. And also in ICs we can't fabricate the inductor or transformer. Therefore, these components also connected exterior for the ICs. And also one more thing, this ICs cannot work with a high power, which is going to produce high power, that is greater than 10 watt, which is greater than 10 watt power. The circuit is not suitable. IC integrated circuit is not suitable for a power ranging above 10 watt. There is a lack of flexibility in an IC because there is a lack. Why? Because the parameter of a circuit will only operated within what we are designed in the integrated circuit. If we need to change any parameter inside the circuit, it is not possible. These are the disadvantages that we are facing IC. Next, some of the classification, we are going to classify the integrated circuits on the basis of fabrication techniques, on the basis of chip size, on the basis of applications. These are the three possible type of classification of IC based on three, that is fabrication techniques, chip size and applications. Next, we move on to classification on the basis of fabrication. How we are going to classify IC on the basis of fabrication process. One is monolithic ICs, thin and thick film ICs. Next, hybrid or multi-chip ICs. Let us study each and everything clearly. Monolithic means it is a single stone where the single chip or single silicon wafer where all the components are placed and interconnected one and another, and this type of monolithic ICs are used widely because of its mass production, its reliability, its low cost, and it is highly reliable. That is why we are going to use monolithic ICs, and it looks like this. All the circuits are connected inside a chip, inside on a single silicon wafer. It is interconnected with the wires like this. These are the terminal. This is how it look like. The monolithic IC looks like. Next, we move on to thin and thick film ICs. This thin and thick film ICs are larger than monolithics but smaller than discrete. This can be used when there is a requirement of high power. We can go for this thin and thick films, and using this thin and thick film ICs we can fabricate only the resistor, the capacitor, that is a passive components but not the active components like transistor and diodes. And also the essential difference between thin and thick is not its thickness or anything, but the how the film is, the method how the film is depositing, that is the difference between thick and thin films. And here we can observe the portions how we are going to, the thin and thick film ICs looks like. This is a resistor that is made by thin and thick film technology. The capacitor and the transistor are placed externally. So, that is what I said, but using thin and thick we can only fabricate the resistor and capacitor passive components, not the transistor or diode. If need to connect means we need externally, we need to connect with the thick and thin IC films. Both the thick and thin film ICs are similar in appearance, but there is a difference in the general characteristics are difference. Next, we move on to another type of IC, that is hybrid IC. The name itself says, means it will having two or more number of ICs connected internally, connect with the help of connecting wires. This is how it looks. That is why it is also called as multi-chip ICs. This is how it looks like. The hybrid IC looks like and it is widely used in a power audio amplifier application because it is having a better performance than monolithic ICs. One of the disadvantage is the process is too expensive, that is why it is not widely used. For mass production itself, the cost is more, the manufacturing cost is more for hybrid ICs than a monolithic ICs. Next, another type, on the basis of chip size, how we are going to classify the ICs. Let us see, on the basis of chip size, we are classified as small scale integrated circuits, SSI, medium scale integrated circuit, MSI, LSI, that is large scale integration circuit, last one is very large scale integration circuit, that is VLSI. Next, what do you mean by SSI and MSI? This classification is based on a chip size. It obviously tells the number of gates or components in the chip. In the small scale integration has 3 to 30 gates per chip. It will be having 3 to 30 gates chip or up to 100 electronic components per chip. This is if the chip contains 3 to 30 gates, then we call it as a small scale integration, and if the chip contains 30 to 300 gates per chip or 100 to 3000 electronic components per chip, we call it as a medium scale integration. This is how SSI and MSI chips looks like. And next we move on to large scale integration and very large scale integration. In the large scale, again the number of gates is increasing from 300 to 3000 gates per chip or 3000 to 1 lakh electronic components per chip, and whereas in very large scale integration again the number of gates are increasing. So, 3000 scale per chip or 1 lakh to 10 lakh electronic components per chip. From all this, what we observed means, as the chip size is increasing, the number of gates also increasing. Why this happening means, before when it is started, this miniaturization, this manufacturing of IC, the IC technology started, comes from SSI, MSI, LSI, VLSI, means as we are using more number of applications, that is the design complexity of electronic device increasing. So, we need to make up the device complexity. So, as the device complexity increases, that number of transistors that we need to occupy in a circuit also increases. So, as the number of transistors increases, these kind of integrations all come into picture. Now, we are in the very large scale integration era, that is ULSI. Ultra large scale integration is a more than 1 million electronic components. Again, it is having even more number of gates, and this is ultra large scale integration chip example, which is Intel 486 of Pentium microprocessor. This can easily specify that even a microprocessor can be designed with the help of a ICs. Inside this there will be a 1 million, just imagine there will be 1 million in this small IC. Let us have a short break. Welcome back after a short break. The previous session we are discussing about the different types of different classification of ICs on the base of chip size, that is SSI, MSI, LSI, VSI, VLSI and ULSI. Now, we are moving to classification of ICs on the basis of applications. On the basis of application, the ICs are classified as linear integrated circuits, and another one is digital integrated circuits. What do you mean by linear integrated circuits? Here the input can take a place on a continuous range of values. Here the input and output will be of linear, both the input and output will be of linear. There we are going to where it is required. If a circuit is of input and output having linear characteristics, then those kind of circuits can be designed using linear integrated circuits. When the input and output relations of circuit is linear, linear ICs are used, and it is of input and output can take place on a continuous range of values. That is, we can take the input where if it is a value of A, then we can also take the value of A at the output also. Example of this linear integrated circuits are operation amplifiers, power amplifiers, microwave amplifiers, multipliers. So, that we can imagine that all these amplifiers, everything comes in a single IC. In a small ICs, all these amplifiers can be designed. Next is digital integrated circuits. When the circuit is either in on state or off state, in those type we can use the digital integrated circuit, and they have a wide range of application. So, some of the example of digital integrated circuits are logic gates, flip flop, counters, microprocessor and memory chips. These are some of the example of digital integrated circuits. Next we move on to, we know the classification of ICs on the basis of fabrication is monolithic IC is also one of the type. In monolithic we know on a single silicon chip the components like passive and active, both the components are placed on a single silicon wafer. So, these are interconnected one another, and this single thin wafer where we are going to place the electronic semiconductor device, that wafer is called as a substrate. How this substrate would be? Let us see how the substrate and what are the steps in the monolithic IC technology. First is a P substrate. How the P substrate is formed and how it looks like. Let us see. Here in the P substrate, a cylindrical P type silicon crystal which is made up of P type material and it is of cylindrical shape. This is how a P type silicon crystal looks, and this P type silicon crystal is of diameter 2.5 centimeter and length is 25 centimeter. This is first we made the P type silicon crystal. This is the first step of monolithic IC process. And then in the second figure where we observe the typical thickness of wafer would be 200 micrometer. This thickness will be cutted from this cylinder using a diamond saw, and the edges will be, and these edges will be polished to get rid of the imperfection. To get rid of imperfection, the edges will be polished, and this is how the wafer is formed. The P substrate, that is what we call as P substrate. On top of this, all the components are interconnected, all the components are formed and interconnected. This is the first step where we get the P substrate in a monolithic IC process. Another step of this process is epitaxial N layer. How we are going to form this N layer? This is this layer, this we already got the P substrate. On top of it N type layer is formed, that is called as epitaxial layer. This epitaxial layer is formed by a gas mixture of silicon atoms and pentavalent atoms is diffused on the P substrate. When top of P substrate a gas mixture of silicon atoms and pentavalent atoms is passed over, then there will be a N type material is formed. This form of thin layer N type material heated on a furnace of substrate. This thin layer is called the epitaxial layer and it is of thickness 10 micrometer thick. It is where the whole, this is a layer where whole integrated circuit is formed, that is why it is called epitaxial, means arranged upon this only we are going to arrange all other integrated circuits. Next we move on to next step, that is insulating layer. After forming the epitaxial layer, we need to protect this from external environment. So, a silicon dioxide layer is formed by exposing the epitaxial layer to the pure oxygen. We will get a silicon dioxide. The sum of the silicon atoms in the N type material will combine with the oxide, pure oxygen, forming a silicon dioxide layer on top of a epitaxial layer. This is how the P substrate, epitaxial layer and the silicon dioxide layer is formed. Next we move on to producing component. By the process of diffusion, we know we have the substrate. If we want to produce any sort of components by the process of diffusion, if we diffuse a trivalent atom, the trivalent atom means we will get a N type material. If we diffuse a pentavalent atom means we will get a p type material. This is how from the diffusion we will get different type of material on top of the substrate, and wherever it is required we can get the transistor or resistor or capacitor or diode. And another process is etching. Before any impurities need to added for a substrate, we need to remove the layer upon the p substrate, that is n type or a silicon dioxide layer we need to remove. This process is called as etching, and also etching process is also required for the forming of contacts, the terminals like terminals, gate terminals. If we need to make a gate terminal, we need to etch the silicon dioxide layer and need to place a metal electrode on top of it to form a gate. That is why this etching process also required. Next we move on to chips. How the chips is formed? Once we have a circuit is placed on a top of a p substrate, all this wafer having is cutted in a like a rectangular box, and this rectangular box is called a chip. Each chip there will be a different types of circuit, and these different types of circuits are cutted, separated, and which is placed, which is mounted mounting panel, and again it is interconnected with the LEDs, which these LEDs are used for interconnection, external interconnection on a printed circuit board. This is how it looks like. This chip will going to looks like this wafer, where the wafer having a different rectangle box. This different rectangle box is called a single chip like this. When we cut and separate from the wafer this chip, it looks like this. This chip is mounted and it is packed with a plastic outer cover, and also the interconnection, the external interconnection can be made from external LEDs from the chip, and the plastic covering will give the protection from external environment. Next we come to the end of the session, the summary. Types of IC technology. There are different types of IC technology that we are discussed, and also on what basis that we are classifying the ICs. That is, one is on the basis of fabrication, another is the basis of chip size, and the last one that we are classified on the basis of applications. And also we come across the monolithic, the very important thing, that widely used monolithic IC technology, and how the process, how the chip is manufactured, what are the different steps, process of monolithic IC technology. The monolithic IC technology consists of different steps, like first one is p substrate, next one in n epitaxial layer and silicon dioxide layer, and fourth one is diffusion, and fifth one is, the last one is chip. How this process will comes in a monolithic ICs, everything we studied in this session. Next, some of the questions of the session is, what is an integrated circuit? Discuss the relative advantages and disadvantages of ICs over discrete assembly. How will you make a monolithic IC? These are some of the questions. Next, the references. For any further references, can refer www.talkingelectronics.com, or you can read the book Electronic Devices and Circuits by G.K. Mittal. This ends up the session. Thank you.